We have complex fraction because we have fraction in the numerator and in the denominator. First, we have to check if we can do some operations in the numerator and in the denominator. Because we have addition here and subtraction, we know that we can add when we have fraction, of course, so we can add only when we have the same denominator. So I can rewrite 2, that this is 2 over 1. I change 2 to fraction, and we have plus m over n, and we have over. And in the denominator, we have subtraction m over n plus 4n over m. Like of course, here must be minus. So like I said, to add or subtract fractions, we need to have the same denominator. Denominator for 1 and n will be n. I have to multiply 1 times n is n. So now, to get n in the first denominator, I have to multiply this times n. Whatever I did with the denominator, I have to do the same with the numerator. And the second fraction, n in the denominator, we don't have to do anything. And in the denominator, we have m and n. So the denominator will be mn. I have to multiply n times m. So I have to do the same with numerator. And m I need to multiply times n to get nm. So I have to do the same with the numerator. So now we will have 2 times n is 2n, 1 times n is n, plus we have m over n. M times m is m squared over m n m. We have minus 4n times n is 4n squared over, I have nm, so I will change mn to n. Because we have multiplication, so we can change the order of variables. So this is equal. Now when we have the same denominator, we have to copy denominator and we just add numerators. So we have 2n plus m. And the same situation we have in the denominator, we have only subtraction, and for subtraction we need to have the same denominator also. So it will be n m, we copy the denominator, and we have to subtract numerators. So it will be m squared minus 4n squared. So this is equal. Now, because we cannot do anything in the numerator and in the denominator, we will change this fraction bar to division. So because fraction bar means division, so we have 2n plus m over n divide, and we have m squared minus, we have 2n squared. So I can rewrite that this is 4n squared, but this is 2n to second power over, we have nm. Now, when we have division of two algebraic fractions, we have to copy first fraction, change division sign to multiplication, and we have to flip the second fraction, so it will be nm. And we see that we have here difference of two perfect squares, so we can rewrite that this is m minus 2n times m plus 2n. This is equal. I just use formula when we have a squared minus b squared, this is equal a minus b times a plus b. In our example, a is equal m and b is equal to n. So now, because we have multiplication here, we can reduce. We have in numerator first fraction 2n plus m, so I can put this whole expression in parentheses, and we have the same expression in the parentheses. In the denominator we have only different order, but we have addition m plus 2n, so we can rewrite that this is 2n plus m. Let's do this. So multiplication of two algebraic fractions, we multiply numerator times numerator, denominator times denominator. So we have 2n plus m times nm over n times m minus 2n, and like I said, first I will put 2n next m, because in the parentheses in numerator we have the same term now. So we can cancel out 2n plus m, and we have n and n because we have multiplication, so we can also cancel that. And what we have now? It will be 1 m over m minus 2n. We cannot reduce anything now, so this is my solution.